Alright, let's talk about this term, this page, the binomial. That's two terms. And we're going to do a difference of squares first, and then we'll talk about a sum of squares, because we've already done this, and we already talked about this a little bit in class. So, in case you missed it in class, let's do it real quick right here. And when I say quick, I mean quick. It's a difference of squares. Difference means I have to be subtracting, and squares means I'm going to have a perfect square minus a perfect square. A perfect square minus a perfect square. Sorry, I have that where you can't see it. Super easy. I don't know why everything's cut off right here, and I don't know why. I must have made some changes and didn't fix it. Okay, so here we go. These got cut off. I had to have made some changes and didn't notice that it cut them off, so let's fix it. You're going to take the square root of the first term. You're only going to need one set of parentheses. And you're going to put it, sorry, not mine, you're going to need two sets in both. Boy, I made a mess out of that. You're going to take the square root of the first term and put it in both sets. You're going to take the square root of the second term and put it in both, this is what it should have said in the first one, sets of parentheses. So let's do an example with this. Let's do an easy one. Perfect square minus a perfect square. You're going to need two sets of parentheses. You're going to take the square root, and you're going to take the square root, and then one's positive, one's negative, and the order doesn't matter. And I'm going to show you why, just in case you struggle with this just doing the shortcut thing. Here's the why behind it. If I just had this, I'm going to do that same problem. It's only two terms, so that means that my A is 1, I don't have a B term, so it is 0, and my C is negative 25. So if I did my X method, find things that multiply to give me negative 25 and add to give me 0, it's 5 and negative 5. 5 and negative 5. So you can do this if you want to do that little extra, that's fine with me, but here's the straight to it. If I have this, perfect square minus a perfect square, yep, two sets of parentheses, you take the square root, you take the square root, one's positive, one's negative. One more, and I'm going to be done with this, and then I'm going to talk about the next part. Because clearly neither of those are a perfect square, but do you have a greatest common factor? Because you need to be checking that GCF first all the time. Unless you recognize it right off the bat, I mean, that's clear to see that's a perfect square minus a perfect square. Easy to tell that's a difference of squares. This is not a difference of squares at first glance. But if you take out that GCF, your greatest common factor, now have a difference of squares. Square root, one's positive, one's negative. Order does not matter here. That can be negative, that can be positive. That's it. That's all there is to it. The other part that you had that's not listed up here for me, but we've already done this. If it's a sum of squares, then my factors are going to be imaginary, and I'm going to show you why. So make sure I'm spelling that right. So if I had this, 4x squared plus 25, same thing. If I tried to do my x method and I found things that multiply to give me 25 and add to give me 0, there aren't any because that's a positive 25. So if I try to do 5 and 5, I'm going to get 5 times 5 is 25, but 5 plus 5 is 10. Or negative 5 and negative 5 is negative 10. So it's not going to work. So if I do this, though, then that's going to multiply to give me negative 25i squared, which is going to make, let me just show you. You're getting confused. I can feel it and you're not even in the room. If I do this, and this is unit 1, we've already done it. If I multiply it back out, 2x times 2x is 4x squared. Negative 10i and positive 10i means that that middle term is 0i, which there's not an I in there. Negative 5i times positive 5i is going to give me negative 25i squared, and the I squared makes that positive. So it checks back out to what I needed. Even if it looks like, oh, I need to go back and do one more up top in just a quick second. I'll do something easy. Obviously not a perfect square plus a perfect square, but I can take out a greatest common factor of 6. And now it is a perfect square plus a perfect square. So I have 6 times x plus 2i, x minus 2i. You take the square root of the x squared, you take the square root of the 4, but you've got to put that imaginary part in it. So that gives me a negative 4i squared, which turns into a positive 4. So let me go back up and do one more example right here, and I'm going to turn my paper on this part sideways just because I ran out of room. I'm going to do an example right here because I should have done this. If I have, give me a second to think about this. Never mind. Here we go. I got it. Perfect square, because that's an even exponent. Perfect square. So when I factor that, oh, that just tore a hole in my paper. That makes me sad. X squared minus 4, x squared plus 4. If you think you're finished on any of the factoring that we're doing, if you think you're done, check it and make sure. Look at this. It is another difference of squares. That's going to factor to be x plus 2, x minus 2, and you still have, well, I can factor this. X plus 2i, x minus 2i, and I hate to drag that into it, but technically I could do that. Chances are, sorry for that bell, it probably just deafened you, I hate that. If it happens to be a multiple choice answer, you are not going to see this part, you're only going to see this. You're only going to see it here. You're not going to see the imaginary part factored out. The reason we teach you the imaginary part factored out is because when we start solving these polynomials, you have to consider those imaginary answers. That's the only reason we have to put it in here, because the standards say so. So, but really, this is, if it was a multiple choice factoring quiz, hint, hint, you probably would see this as an answer, but you will not see this. Okay, that's all, folks.